Good morning. Thank you for coming to this conference and to visit this session. This next session, I'm going to introduce data mining algorithms. So there are many algorithms. I will introduce the most popular ones. And of course, even for the most popular ones, I need 2 sessions. My name is Dejan Sarka. I am in the field for nearly 30 years. And actually, my career started with working in university for statistics. I did a lot of statistics and early data mining in 80s. And then I switched more to Microsoft and SQL Server side. And of course, there is strong support for data mining in analysis services, in Excel, and now even in Azure machine learning. So, if you have any question, even after the conference, these are my contacts, email, Twitter handle, so please do not hesitate to contact me. Maybe I will need some time to answer, but I will try to answer all of the questions. So what I'm going to talk about, this first part, I will introduce data mining first, so you get the idea what exactly this is. And then I'm going to talk about predictive algorithms, predictive or also classification algorithms, how they work. Naive Bayes, decision trees, neural networks, and logistic regression, and also describe how we can evaluate the efficiency of these models so we can decide which one to deploy in production. Let me just jump here. This is for the second part, so there will be no introduction to data mining, but I will talk about linear regression, regression trees, support vector machines, forecasting with time series, clustering, association rules, and sequence clustering. So even more algorithms in the second part. Apparently somebody forgot this, thank you.
It's not mine.
Nice device. It doesn't look too smart. Okay. So, what is data mining? Let's start. So you know that this is maybe the most advanced data analysis technique we got, the most advanced part of business intelligence. And with these products we got, and packages, especially with Microsoft Suite, less with R, which is more like programming language, but especially with Microsoft Suite, you use data mining like it was a black box. So you feed it with data and you get some results. Well, the problem is, you know, if you give an ape computer, this ape will not become a mathematician. It will be just an ape with a computer. That's it. So with a calculator. So you need to know a bit more how these things work. And I'll try to unveil this black box. And once you have this knowledge, then you can realize and understand when to use which algorithm, why some algorithm gives you better results than another. Also maybe to realize what are the dangerous points. So not all algorithms are useful for all kinds of data, and because it is kind of black box like analysis services or Azure ML, you will simply get some results. Although it would be better to use your experience, evaluations over the top, predictions over the top, and not use data mining at all for a specific task, because some algorithms are very prone to give you weird results with some specific kinds of data. Okay. Also, sometimes it's even the problem how to interpret the results. You know, data mining is business oriented, so after you did all of the modeling and trained the models, you want to use these models to improve your business, whatever, improve your return on investment. And if you don't understand properly the results, of course, it is hard to use this in production. So this is what we are going to talk about, and also show how these algorithms work in analysis services in a simplified way in Excel, and in a more complex way in R. And since R is also supported in Azure ML, this means that also this knowledge is applicable to Azure ML as well. And of course, I need to say also that all of these data mining algorithms are public domain. So this is kind of habit in data mining field. So it started to develop in 50s with statistics and then went to data mining in academic world. So it was always like this. All of the algorithms were public domain. So the difference is how these algorithms are implemented. So what I'm trying to say that what you will learn today is also applicable on other data mining products like SPSS, SAS. They use the same algorithms. And also, for example, we'll talk about sequence clustering, which is an algorithm developed by Microsoft. And Microsoft respects these rules or this conduct of behavior in data mining area. So also sequence clustering algorithm is published completely in Microsoft research sites, so competitors can use this information and build their own solutions. Now a little bit of my assumptions. So this is not introduction to SQL Server analysis services, Excel or R. I do expect that you know at least one of these tools. Do not need to know all of them. And also I will use Visual Studio, SQL Server Management Studio, Excel, R Studio. Nothing specific there. I will not spend a lot of time on the tools. So I expect that you know at least one of them. And I will show examples in multiple tools. So even if you don't know all of the tools, it doesn't matter. You will get enough information. But the focus is on the algorithms, how the algorithms work, how they get their results. First, a little bit of definition of data mining. Might be especially interesting to try to separate it from statistics and from machine learning. More or less, many times we use these terms even as synonyms. So let me start with the first, little bit more formal definition. The process of exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover patterns and rules. First, I would like to comment these large quantities of data. You see, data mining started to develop from statistics. And in statistics, we are working on samples. And we have two different branches of statistics, one that works on small samples and one that works on large samples. And small samples means 30 cases or less. That's small. Large means 200 rows or 200 cases or more. So this is large for data mining. It doesn't mean millions or billions of cases, 200 and more. And from statistical sampling, you can learn that like 20,000 cases is more than enough to learn good patterns. And you never need more than 100,000 cases for data mining algorithms. So if we talk about the amount of data you are analyzing, data mining is not dealing with small samples. This is different from statistics. Now this big is compared to statistics. What about machine learning? Machine learning is definitely using all of data mining algorithms. So whenever in Azure ML you are using one of these algorithms, you deal with the same samples. These are complex algorithms which scan data maybe 1,000 times in 1,000 iterations before they get the result. So if you fit these algorithms with millions and millions of rows, you will wait for days or even weeks before you get the result. And also the results will not be better because these algorithms come from statistics and they are tailored to work on samples. That's it. So feeding them with more data doesn't give you better results. Yet there is a part of machine learning that is really focused on machines only. And this part uses simple mathematics, but can gain a lot from huge amounts of data. And this is the part where really, as I said, machines learn. So for example, we all have smartphones, and you know these keyboards are very small, these keys are very small, and yet you don't make many errors. This is not because you would be so good at typing, and you would have so precise fingers. This is because Google and Apple and Microsoft spent a lot of time to teach this software how to recognize what you want to type. Or, for example, Xbox can detect your moves, right? This kind of algorithms, these are pure machine learning algorithms. These algorithms can benefit from more data, but mathematics behind is kind of simple. Just learn from the example. So more examples, better results. The other part, and what you see nowadays, if you go to Azure ML, you will see mostly or only data mining algorithms. These are currently available, only data mining. So in this part, machine learning and data mining are synonyms. And finally, also worth mentioning, data mining and machine learning, this is business, statistics is science. So the main difference is really funny, but the main difference is with statistics, you test the hypothesis. If you get the result that hypothesis is wrong, basically you get no result. This is result for science. This is not result for business. Customer will not pay you. So you try with a different algorithm, change something in your data set you are using for training and so on until you get some result. So it's not science. So we are deducing knowledge by examining data, and then we use this knowledge to make predictions, estimations, forecasts, and so on. Now, also worth mentioning, if we compare this to online analytical processing, this is still model-based. We create all-up cubes in advance, we define dimensions, attributes, hierarchies in advance, and then we are limited there. And we try to find patterns by visually analyzing this data. Data mining starts from the other direction. We just include all possible attributes we got, and then it's mathematics behind that tries to find these patterns that should be useful for us. There are two main types of data mining, so-called directed or supervised data mining. Here is where we have a target variable. By the way, in data mining terminology, we are analyzing cases using their variables, and this is terminology that comes from statistics. Basically, what you are analyzing is a table, and cases are rows and variables are columns. So here we have a target variable that supervises the training of the model. So this is what we are going to talk about in this first module. For example, decision trees. Target variable denotes some kind of decision, true, false, or even more classes, but it's discrete. And then you use input variables to try to explain how did we come to this decision. And once you got the knowledge, you save this knowledge in a trained model, and then you use this knowledge for predictions of the target variable on new data. So you get some new examples with known input variables, so you try to get the value of the target variable to predict it. Now, estimation is very similar thing, just that the target variable is a continuous one, like income or age or something like this, a continuous variable. And you use one or more continuous variables as inputs, but also you can use discrete variables as inputs, and then you try to estimate the value of the target variable. So for example, if you are in a bank and you have a new customer asking for loan, you can try to estimate the family income based on the demographic data you got from the customer. And forecasting is again something similar. Similar to estimating, you try to forecast some target continuous variable like sales amount in next year, so you can make better plan, better budgeting. The main difference is that prediction and estimation, you can check these estimates and predictions immediately. You know, like you have this customer asking for loan, you estimate the income, and then you can ask. For forecasting, you can check the quality only after time You don't know the number for the next year yet. But after this time comes, you see how forecast were good or bad. Undirected or unsupervised data mining, you don't have a target variable, you just try to find some patterns from the combinations of the values of the input variables. And what are these patterns? Well, for example, we are searching for combinations of products that are sold in a single transaction, market basket analysis. And we are searching for groups or clusters of our customers. So we see if there is any specific grouping inside my customers, employees, whatever. So classical clustering. Even some visualizations can help you here, although I would not count these descriptive statistics and visualizations exactly into data mining. It's probably more like preliminary part of data mining. So what are typical business questions? As we mentioned, what is the credit risk of a customer? Are there any specific groups? What products do customers tend to buy together? So what will be my sales amount in next time period? Potential number of customers in a specific store. And how is my website used? Can I improve something here? And of course, these are just very well-known questions. Of course, it's only up to your imagination. You can use data mining for whatever you wish, whatever needs to be improved by better predictions. But there is a time and place for everything. I will tell you my experience with word in wrong time and wrong place. So a couple of years ago, I broke my knee, so I had a couple of surgery operations. And of course, I was there, and one operation and waited for 2 weeks, and I was bored. Then once I said to one of the doctors that I could help them lowering the mortality rate in this hospital, and all I get was extra dose of sedatives. So, word out of place and time. So, okay, but basically it's up to you to get the ideas how to use data mining. I was prepared to do it for free, just to take them. But why not? I mean, I'm still sure I could help them lower the mortality rate. I'm still sure, but okay. I'm not trying to do it anymore. Of course, even advanced spam filters are already using some data mining algorithms. Namely, naive Bayes is used for searching for spam emails. And of course, usage, cross-selling, these affinity grouping or association rules. This is first thing you need if you want to have some web sales. Without this kind of analysis, you are doomed to not to be successful, because this is something that all of the major vendors already implemented. So this is not even something that would give you any advantage. It's something you simply must have if you want to have any serious web sales. Fraud detection, classical for credit card issuers, online banking, classical data mining task. And also a very tough one. And I will come back to this case where in a slide or two where I will define continuous cycle of data mining. Churn detection. This is for all kinds of services, especially services where the market is saturated, like mobile phone providers. So the market is saturated, so you can't get new customers from anywhere, right? But you can get customers from your competition. Okay, but you don't know these customers. What you can do, you know your customers, so you can prevent your customers to leave you. So this is what you are searching, which customers are about to leave you, and what do they expect, so they will stay with you. Okay, to customer relationship management applications should always use some business intelligence. This is about knowing your customer. And you should learn with all kinds of BI tools. So CRM is not about spamming your customers with hundreds of mails, it's about learning about your customer. You know, your local butcher knows exactly all of the customers. When I was young, I was always a good mathematician, but I was always impressed by these butchers. They were always faster in calculating, and the price was always exactly the amount of money my mother gave me. You know? So I was always impressed. So this is kind of natural data mining they are doing all of the times. But once you go to web sales or bigger retail store, of course you can't know all of the thousands or millions of your customers, so you need to learn something with automatic tools. Okay. And of course, forecasting is always welcome for better budgeting, better planning, and so on. So virtuous cycle. You see, in many cases, or in most of the cases when you go to production, this is a never-ending story. Of course, you do most of the work in the beginning, but you should be prepared to improve all of the time. Now, to go back to fraud detection, why? Well, fraudsters learn. So patterns you learn today will be obsolete in a year or even earlier. You know. So you need to be prepared to implement data mining in a continuous virtuous cycle. You must identify the problem, either a new problem or identify that there is a problem with your existing deployment. And then you transform this problem to patterns and rules. So this is the part where you do this actual data mining. And then you evaluate your models and act, which means deploy in production. It could be just an overview, so you get the understanding of your customers, or you can use predictions online in your transactional applications to immediately get a warning, this is a potentially risky customer, and so on. And then, how do you know that your models are obsolete? Well, you need to measure the efficiency, and you need to measure the efficiency over time. So when the efficiency drops, then you know that it's time to react. For example, for predictive models, you see, I will just give you an example on fraud detection, how you can measure this over time. First, it fits very well in other BI parts. So where you measure things over time, this is in data warehouses and dollar cubes. So data mining model is a perfect candidate for a new dimension in a data warehouse. And then for measures, you have predicted values. And of course, in data warehouse, over time, you get the actual values. So you can always compare how good the predictions were. But it's even possible for tasks like fraud detection to have one step in between the predicted and the actual value to react even earlier. So you see, how do you predict these values? Well, you learn from existing frauds with some supervised algorithm like decision trees. And because you have target variable, the predictions should be quite good. But then you also learn the same thing through unsupervised algorithm like clustering. And try to predict frauds with clustering. Results should be better than randomly taking transactions and try to randomly define this is fraud, this is not fraud, but worse than decision trees. Because you don't use any previous knowledge. You are just searching for transactions that do not fit into any groups. You see, this is the same thing as just one step more from customer segmentation. We are segmenting transactions, and then we find transactions that do not fit well in any of the segments, so they are weird. So we inspect those. So, of course, with supervised algorithm, you should get much better result. But when the gap is starting to close, it means that without previous knowledge, you can get better predictions that with previous knowledge, so the model with previous knowledge is definitely obsolete. So you can react even before your predictions fall to some rate that is not acceptable by the business. So you get, again, more or less random selection of transactions which you define as fraudulent. And of course, once you measure that there is something problematic in your model, you identified a new problem, so you start a new cycle. And this transform part, this is the actual part when you do the data mining. And business data understanding, data preparation, this is the part where you typically spend 70–80% of time. This is how it goes. And then you do multiple models, and then you evaluate those models, and then you decide which one will be deployed. Okay? So business understanding is connection to identify part, and deployment is connection to the act part. And you have internal cycles here. You might go back, prepare more data. Now, also worth mentioning, how much time should you spend for this? And how do you know when it's enough? The problem here is that you don't know. You see, you still have to feed data mining models with different data sets, different variables, and then also the right variables are many times very important. And different data sets, even different rows, might give you different results. And of course, you train with multiple algorithms which accept multiple parameters. So typically, you start this with a proof of concept project, and you say this is 1 to 2 weeks, 5 to 10 working days. And in this proof of concept, you expect that business understanding is there. You have subject matter expert always online if needed, and you have IT people always online, so you don't deal, how do I get the data? Data is prepared, this is the assumption. Data you need. And then you do your preparation and data understanding for data mining. And let's say that you signed up for 10 days proof of concept. So you simply prepare multiple ways of the same data set in multiple ways, and you do this for 7 days. And then for 2 days, you do this modeling, multiple algorithms, and then half a day evaluation and half a day present the results. Is this enough? I have no clue. Maybe if you would spend 5 more minutes, right, you would get a better algorithm. But with experience, with business and data understanding, you can focus in the right direction, turn in the right direction immediately. And definitely this is just a proof of concept. Don't forget on the full cycle. So even if this is not the best model, who cares, you know, because you are measuring the efficiency, so you can do more testing and additional models later. This first proof of concept is just to see whether you are able to get some reasonable patterns useful for business. And also data flow, you start with historical data sets from relational source, cube, or even big data, do some ETL, prepare, and then you train the models. Once they are trained, deployment is just model browsing. Especially graphical viewers are useful. You can deploy them in reports, or you can use them in a new data set with a new data set to make predictions. And then you can, again, create reports from predictions or use them in line of business applications. And of course, don't forget about measuring over time. So you deploy, very nice measuring over time is deploying data mining model as a dimension of an OLAP cube. So, to finish this part, so we have reporting as part of BI, which is the simplest thing, right? You have very limited interactivity. You can enable some drill down, some filtering, maybe interactive sorting, but this is more or less it. You cannot even, I don't know, pivot a table interactively from a report. With online analytical processing, you have predefined grouping buckets, you have levels of hierarchy, and inside this, structure, you can change your reports online. So you have report structure dynamic, but still mostly you are limited with overall structure. If there is no hierarchy defined, it is kind of hard to work with such cubes. And of course, mathematics in OLAP is very simple. Typically only 4 basic operations. You are comparing sales in this year with sales from last year. With data mining, you still define the attributes you are using. So there is some kind of structure, but that's all. And then data mining algorithms try to find the structure inside this data. So with SQL Server we have analysis services which must be installed in multi-dimensional and data mining mode. Analysis services tabular doesn't have data mining engine. We have two components for text mining, term extraction and term lookup in integration services, and also full text search and semantic search can be used for additional, let's say, text mining. But basically the analysis services is the engine. In Excel we get data mining to Excel with Microsoft Office data mining add-ins, which are free downloadable add-ins. And this is the part that still works in Excel 2007, 10, and 13 only. It doesn't work in Office 365 yet. So this might be also a reason why not to switch to the cloud version. Because this is in Excel only. Okay, templates for Visio. Nothing special, but you can draw a decision tree in Visio, but these tools will see data mining client for Excel and table analysis tools for Excel. This one first is more developer oriented, and this is more business users oriented table analysis tool. So very simple to use, and but worth mentioning, Excel doesn't become data mining engine. You need analysis services. So Excel is connected to analysis services, and data mining add-ins are reading Excel data, sending it to SSAS. SSAS is doing the training, and then Excel data mining add-ins are sending DMX, data mining extensions queries, to retrieve the results and make predictions and show you the results graphically. And I will also show you this in R. So what is R? R is a free programming language and data mining engine for statistical computing graphics. And you have multiple versions for various operating systems. And it is developed in academic world. So it's completely free for use. It brings also a command line interface, but also there is another group of users that created R Studio, which is a very nice integrated development environment for R. R looks perfectly when you start to deal with it, but please note that having things completely for free is not always an advantage. So there is big issue with consistency of commands, consistency of ways how you can achieve the results in R. Also, you will see from the examples, you have core R, and then you install additional packages, and you install them on the fly in your session. So there is a single command, install package, that produces the results. So R engine goes to some specific website, downloads compressed file, uncompresses it, and installs it. And now try to do it in some bank. Online, I will just issue a command and it will go somewhere and download something. So R is very useful maybe in initial stage for data understanding and so on, but not so for production. Now, I'm not talking a lot about Azure ML here, but Azure ML is somehow trying to use R in a controlled way. So not all packages are supported, they are preloaded at Microsoft side, so you don't need to load them. But of course this limits the functionality. But at least Microsoft is trying to make some order here, so it's more business oriented. Okay, so now let's switch to the algorithms. So first algorithm I'm going to describe is naive Bayes. So this is a very fast algorithm, not so sophisticated. So this is classification and prediction algorithm, not so sophisticated, so the results might not be so good as with decision trees I will describe later. However, this could be very nice algorithm for your initial stage to get first comprehension what to research. Also, this is the algorithm that is used currently in some of the most advanced anti-spam applications. Why? Why not more advanced algorithms? More complexity means slower processing, and emails should be processed very quickly. So little bit of formal definition, and I will describe this graphically. So naive Bayes calculates probabilities for each possible state of the input attribute, of every input attribute, given each state of predictable attribute. Wow, what does it mean? Let me explain this graphically. So imagine I'm buying a second-hand car. And let's say from overall experience or from car magazines, I learned that around 30% of second-hand cars are faulty. So my initial probability, I don't have a clue, I don't know anything about cars. So my initial probability to buy a good car is 70% or 0.7. So now I have a friend which has some knowledge, mechanic or what, and he decided that he will take a drive with me, and based on this drive he can declare a car as okay or faulty. And of course he's not always correct. So if the car is faulty, my friend will recognize it as a faulty in 90% of cases. And if a car is good, he will recognize or she will recognize this car as good in 80% of cases. So altogether, my friend would declare, you see, 30% of 90 is 0.27, and this is 0.40. So 41% of cars would be declared as faulty, and 59% of cars would be declared as good. Now we can reverse this. Now we can reverse this tree, reverse the tree, so I have 59% of cars declared as good and 41 as bad. But if we reverse the tree, remember if we go here, 27, 14, and so on, so we see that from this 41%, in 2/3 of cases my friend was right. These are the cases where the car was actually okay and my friend declared it as faulty. But when the car was declared as being okay, it was 95% of time that it was actually okay. Now, this is the result. Now I'm using my friend's declaration and I'm buying a car that my friend declared as okay. So my probabilities that it is actually good are 95%, which is much better than probabilities I had initially, right? So these posterior probabilities are much better than a priori probabilities, where I had only 70% of chances. Now imagine you have this table. We have products and we have data about color, class, and weight. And I have some missing values. Now this example shows you how you can use data mining also for advanced data quality problems. Advanced analysis of data quality problems. So you have nulls, you have missing values. You want to get rid of these nulls, right? Now, in your big table, you have nulls in multiple columns and multiple rows. You cannot just go to end users and say, do this, insert data everywhere. You try to focus end users to the most important parts. So the idea is try to explain maybe null in one column leads to null in another. So we can focus on this column. So imagine that we have this data. If color is missing, also in 80% of cases, weight values are missing. And if class is missing, 60% of weight values are missing as well. So we calculate these probabilities. So if color and class are missing, the joint probability is 0.48. However, the joint probability that if color and class are not missing, that the weight is missing, is the rest, 0.2 multiplied by 0.4, which is 0.08. So we can normalize this between 0 and 1, and we see that the likelihood that weight is missing is much higher when color and class are missing than when color and class are known. So you can normalize this to 1, right? And you get that if color and class are missing, you got more than 85% of, nearly 86% of probability that your weight is missing, and only 0.14, only 14% of probability that is not missing. So what does it mean? does it mean something for reality? I don't know, but you got the idea. First focus on color and class, and then you hope that weight will suddenly not be missing. But you got the idea where to focus, where to start solving the problems. So, usage, classification, assign new cases then with predictions to predefined classes. So, categorizing bank loan applications. If you have segments predefined, use them for predictions. With clustering, you don't have predefined segments. And get a basic comprehension of data. So let me show you some examples. So I will just add a new, starting with analysis services project. Analysis services multidimensional and data mining project, definitely. And here, this is not the one I need, okay, this is the one I need. I will define data sources. So first, my data source for these predictive algorithms will be the vTarget mail view from the AdventureWorks DW database. And I will use this for decision trees, MyOBS, and other predictive algorithms. So this view joins demographic data from customers with a flag at the end telling whether this customer purchased a bike or not. Now, my target here is to get understanding what leads to value 1 in this column, to purchasing a bike. Imagine I'm doing a new marketing campaign. I have a list of potential customers, so I want to see which one are more probable and which one less, so I can focus first on the most probable ones. Okay, so this will be my source. So let me go here. Maybe I can even simply copy the query. For data source views, data source is just a connection string. So connection string to my local AdventureWorks DW 2014 database. And I'm using these options inherit. What does it mean? It means how analysis services will introduce itself to SQL Server. So inherit means for processing, training the data mining, it will use its own account. For predictions, I will do the predictions, it will use my account, it will impersonate my account. Okay. Now I will create a data source view from this data. Data source view is actually metadata from SQL Server transferred to analysis services database. So it's used by analysis services to pull the data to create prediction queries and processing queries. And of course gives me the definition of data mining models. Please note that I created an empty data source view. I don't want to transfer the complete table. I will just add a new named query here because I have, let's say, target mail. I have query prepared with only the data I need. Okay. That's it, and I will also set logical primary key, and I'm prepared. So now I will go to this folder, mining structures, and create a new mining structure. So what is a mining structure? Mining structure just gives all possible columns for multiple mining models. It's just a way how you can faster create mining models in analysis services. But it's really not important for training or for predicting. It's just for development. And if you have mining models that share the same structure, you can compare, evaluate them in a very simple way in analysis services. So I will use the same structure for multiple predictive models. However, this is not even a namespace or a schema for this mining model. So mining model names must be unique inside the database. Even if they are in different structures, the names must still be unique. So it's just like development time and testing time object. It's not a real object, just virtual object, the structure. And of course, you can also compare models that do not share the same structure, but you have to query them manually with DMX queries. So that's why. So I'm using data from existing relational database, and I will use NeoBS. From this data source view, target mail is my case table. And you see, I need to define for NeoBS at least one predictable column. This is what it says, because it's supervised algorithm. So my predictable column is bike buyer, and of course, key was already selected. I need at least one input column as well. Key, predictable, and input. So all others will be input. Commute distance, education, gender, house owner, flag, marital status. That's it. All of this will be input. Check the content type. All of them are either discrete or discretized. Okay, and they are not discretized. They are just discrete. If they are discretized, they will ask you. It will ask you also what kind of discretization do you want to use. I know they are just discrete. This is important part, percentage data for testing. You see, how will I test the predictive models? Testing, predicting, evaluating, which gives you better prediction, is kind of simple. You simply set aside part of the training data, you train the model on the rest of the data, and then you use the model to try to predict values on this test data. And the outcome of bike buyer is known. So I can simply measure how many times the predictions were correct. The important part is that you do this statistically randomly, otherwise you can build pattern in a split of data. Analysis services can do this for you. If you use R or, I don't know, prepare data manually, then you have to take care to do this split randomly. For example, just to mention, if you are using SQL Server as a source, there is nothing in Transact SQL that would really, out of the box, that would really give you statistical randomness. Rand function is useless. It's not even close to statistical randomness. Some people try to use unique identifiers, GUIDs, and say select top 30% from GUIDs. GUIDs are not statistically random. Uniform distribution is not random distribution. So how do you get this manually? You have row sampling and percentage sampling transformations in SSIS, or you simply use .NET security classes to create your own random function. And then you create values in a table with this random function, and then you can select top 30. In Transact SQL, there is nothing out of the box that would give you statistical randomness. So I will call it target mail tm dt. Okay, and I'm done. So this is my first NeoBS. I could set up some algorithm parameters. NeoBS is simple. Maybe worth mentioning, it works on discrete columns only, discrete values. You cannot feed it with continuous variables. And this is what is defined as discrete. So if the algorithm will find more than 100 distinct states, it will fail. The processing will fail. The result will be, you are feeding me with a continuous column. So let me just deploy this. And processing is this part. This is where the training of the model happens. And if you have a complex algorithm like neural networks or clustering or decision trees and you feed it with millions of rows, it can take weeks. Now I'm done. Now I can start using this mining model. So Microsoft has very nice viewers for this part. Unfortunately, they are not there in Azure ML yet. But these are the viewers. So these are the columns that have the most influence on bike buyer. So number of cars sold is the first one, commute distance is the second, education is the third. You see, not all of the columns met the threshold, some are not important. Okay. And this gives you the idea about distribution of these input attributes in classes of target attribute. Remember how NeoBase is working? Calculates the distribution, frequency distribution of input attributes in classes of target. So in class 0 or in class 1, I can see number of cars owned in class 0, not bike buyer. I can also show the legend so we can see better. So most of people have 2 cars when they don't buy a bike. When they buy a bike, they have more 0 and 1 cars than 2 cars. And what else? Let's see what are important patterns here maybe. So commute distance for value 0, right? For not buying a bike, for value 0 is either 5 to 10 or 10 plus or 0 to 1. So 30% 0 to 1, but for 1 it's nearly 40% of 0 to 1 miles, so commute distance might be also important. And with higher commute distance, of course, less bike buyers. I can show this also in different way. So what favors value 0 and what favors value 1? Number of children at home, 0. And okay, marital status doesn't give me a lot of information because married or single is nearly 50-50. I can get rid of this kind of attributes with attribute discrimination, so compare directly what forces value 0 and all other states, which is in this case, of course, only state 1. So you see, these are the most important attributes and values. 0 cars forces buying a bike, 2 cars not. Interesting that with more than 2 cars, people tend to buy more bikes again. And partial high school, not buying a bike, and region Pacific buying a bike. Commute distance, not buying a bike. Total children 5, apparently with 5 children you don't have money for a bike anymore, and so on. And so on. Okay. So just to show you how does it look, how does the model look? This is data mining model. In analysis services, this is one row. So this is a table where I have values for the bike buyer, and this is a column, node distribution, and you see a column is a table. So analysis services data mining supports nested tables. So let's say if you would try to use this in SQL Server, SSIS, or Power Query, Power Pivot, you should flatten this with the MX query. And this is the node for number of cars owned equals 3. So in this node, we have nearly 60% of bike buyers. Okay. So this was NeoBase. Now let's go to decision trees. And this is, maybe you noticed when I created NeoBase model, when I started to create mining structure, the wizard offered me drop-down list of algorithms with decision trees selected. This is kind of selected by default. There is a reason behind it. This is by far most popular data mining algorithm. And why? Because it is very, very useful. It's not so simple internally. It's quite complex internally. However, it gives very, very good predictions in many cases. And very stable usually as well on different data sets. And first of all, once you get the model trained, it's very simple to understand. Simple to understand means you can act upon it. If you don't understand what you get, it's kind of hard to decide what to do. So again, let's start with formal definition of the algorithm. So formal definition is, this is the recursive partitioning algorithm. So it means we partition the data, and then we partition partitions, and then we partition those partitions, and so on. So first we start with all cases in big box. And then the algorithm tries to split this data using every single input attribute. And it can get even more complex. Those of you who were yesterday in my introduction to Azure ML, R and Azure ML, You saw, maybe noticed that in Azure ML we have multiple decision trees algorithms. This is not any difference from this one. They are using things they are already developed. Just that in analysis services this is much more complex. So through parameters you can get different decision trees. So in analysis services it tries all possible breaks using every single value. So tries full-blown break. Let's say that you have education in 5 classes. So the algorithm will try full-blown break in 5 subclasses, and also binary breaks, like using education level 1 and all others, and 2 and all others, and so on. Or less than 2, more than 2. So you can imagine that this takes a lot of time. Just for this initial break, we need to scan the data, I don't know how many times. But then we are not done. Then we have sub-branches, right? Now, first, before we go to the second level of partitioning, we have to decide which division we are taking with us. So we are taking this break that gives us the purest results in terms of the target or supervising variable. So imagine I have bike buyer, yes, no. With 2 values only, just frequency distribution can be a very nice measure. So frequency distribution in all possible subnodes. So with this break, let's say binary break of over the, I don't know, marital status, I got 2 subnodes. Initially I have 50-50, 50% buyers, 50 non-buyers. Now in these 2 subnodes, in one subnode I got 30% non-buyers, 70% buyers, and in the other 70-30. If I break over gender, I get 60-40, 40-60. So probably break over marital status is better. Gives me purer classes. With more states of target variable, this can become more complex. We have different measures of purity. And I will not go into all of details, but more complex like entropy, Bayesian scoring. What does it mean? Just to get the impression how complex the algorithm is. So to check the purity of the splits, it uses in every single node the naive algorithm. Imagine this. Now you can imagine why it takes so long to train the model if you feed it with too much data. Just to decide which split to take. But then we go to the second level. Repeat the split. And try all possible breaks. We have a problem where to stop. This is the problem also known as overfitting. This is an issue with decision trees. They try to please you. So finally we could go, to the splits where I can have in each branch 1 case only. And in one case I can have only 1 target state, so 100% purity. So you have to prevent this. So you have to either cut off, post-prune these not useful branches, or prevent the tree growth, right? So stunt the growth of the tree before it grows to deep. So you test the nodes in advance. And tests are very simple. You can just check how many cases you will have and say if there are less than 20 cases, I'm not going there. And there are also again more complex tests, like the complexity penalty to punish the growth in depth, and so on. Post-pruning are even slower methods because first you fully grow the tree and then you cut off useless branches. So even more complex. Imagine this example. So we have Woodstock movie, we have population that watched. Some of those 55% liked the movie, 45 didn't like the movie. Now we have also education level and age groups of these viewers. So what we do is try to find what leads to liking this movie. So who is the target population? So you see, trying to split using every single value of every input variable. So split at age 45, at age 40, and so on. And then we keep the split that gives me the purest classes. With the age of 35, those who are older, 35 or more, I have 73% who like the movie. With those younger 33% didn't like. And then I continue splitting these classes using other input attributes. So education, in the upper class, older people, I can make a split at education level 2, and I get very interesting class with 87% of people who like the movie. And with younger people, education level 5 gives me the best possible split. So I have in this class 83% of people that didn't like the movie. Please note that some branches don't improve the results. So this branch might be useless, not useful for predictions. Doesn't give me much new information. So classification and predictions. So prediction which customers will leave, right? Which transaction is a fraudulent. Explain any kind of reason for a decision. So let me show you now a couple of examples. Now I will show a little bit more examples. Now we know analysis services, so I will also show examples in Excel and R. Okay, so first in analysis services, because I'm sharing the structure, I can create a new model in a very simple way. You see, new mining model, right-clicking on existing model, all I need to do is, great. So I called the previous model TMDT like decision trees. Okay, so I will call this one TM naive base. Now I'm using the decision trees. Now I noticed, okay, let's exchange the names. And it's done. You see, I have the same structure, the same key input and predictive columns. I don't need to start from scratch. That is the good thing about data mining structure. Now let me deploy it. Okay, I have 18,000 cases, so we will not notice a big difference from processing decision trees and NeoBS. However, with more cases, you now understand that it's a big deal, big issue with feeding decision trees with a lot of cases. Now let's go to mining model viewer and let's check the NB model, which is the decision trees model. Let's hide this Legends and Solution Explorer. So this is my tree. By default, I have 5 levels expansion, and background is colored based on number of cases. So darker background means more cases. This doesn't give you a lot of info. Of course, initially you have all cases, so it doesn't make sense. But let's say I'm interested in bike buyers, so I want to color things based on value 1. And now I can easily see, now it's colored based on percentage of bike buyers in a class. So this is an interesting class, this is an interesting class, and now I can learn how did I come here. And this line gives me the distribution of buyers, non-buyers. So you see larger red part gives me also darker color here. Now I can read the path. I started with all cases, went to region not equal North America. You see a binary split was, no, region equals North America, so full-blown split was used. Sorry, I read and maybe I have dyslexia. I don't know where I read not. And number of children at home equals 2, and total children not equal to. For the last part, the binary split was used. Then I came to this path, and now I can also show the legend and can read this. So in this class, I got more than 81% of bike buyers, and this is the full path. Number of cars owned equal to. Remember that number of cars owned equal to actually enforces not buying a bike. But even with 2 cars, if the person is from North America, has 1 child at home, and not 2 children in total, we still have a good probability that this person is buying a bike. And also maybe I can check some not so useful classes, like here, go more in depth. Come on, go away. And maybe I can later get some interesting patterns, or maybe here I will get some interesting patterns. I will zoom a bit, it's kind of hard with zoomed out so much. You see, even in this 6th or 7th level, I came to something interesting. Wow, I have nearly 100% of bike buyers in this class. Right? But you see, I have only 13 cases. So this might be a branch that was overfitting. Now, you see, I have also the other viewer dependency network. And first, the most influential part is number of cars owned. Then it's region, and then it's total children. So number of cars owned, region, total children. Let's go to NeuBS. NeuBS agrees with number of cars owned, but then the second is commute distance, and the third is education. Different results, you see, different algorithms give you different results, so we'll have to evaluate them. Now, let me switch to Excel, and let me read the data from SQL. I will use the query again, from Microsoft Query. So, AWDW, and I will just copy the same query. I think I still got it here. Okay. Okay, and return data to Microsoft Excel in a tabular format. Now I have two kind of data mining tools in Excel. I have table analyze tools, which is more business oriented, and I have data mining tools, which are more developer oriented, so you can use them even instead of Visual Studio. And here I have classify tool, which tells me that uses decision trees. So let me use this tool. And this is my table I'm going to use for training. Column to analyze is bike buyer. Input columns are all others, not customer key. Okay, I will also not use bike buyer. I will not test here, I will test in analysis services, so I will not leave any data. And I'm doing the processing. So what is Excel doing? Reading the spreadsheet data, sending data to analysis services. Now it's training the model, so actually now Excel is not doing anything. Analysis services was working. And here are my results in Excel. And you see Excel is using, with data mining client, completely the same viewer. I can copy this to Excel, okay? And when I copy it, it's just a static picture. Now let me go to this table again, and let me go to table analysis tools, and I will use this analyze key influencer. So you see it's a little bit more business oriented terminology. So I'm analyzing bike buyer, and I'm using all other columns except customer key and bike buyer for analysis. And now I'm running. And now I will tell you what this is using. It is using NeuBS. So it's adding reports, not using data mining viewers, using internal Excel tools. So Excel tools like data bars. So here is this discriminant analysis, what favors 0, what favors 1. Similar like we had with data mining viewer for NeuBS in analysis services. However, this time with Excel tools. And the relative impact, same data bars shown in a different graph. So this was table analysis, NeuBS in Excel. And now the ugliest part R. So first I already pre-installed all of the packages, but this is how you install. OWC connector for R, install packages, and it goes somewhere, downloads zip file, unzips it, installs it. As I said, try to do it in some bank. Now I'm loading this in memory, and I'm connecting to analysis services using the latest security science for the passwords. So read the data. In a data frame, I'm not going to talk a lot about R, but we are working on data frames, which is kind of matrix. It's the closest thing that exists in core R, the closest to the table. R is not working on tables, so we have kind of matrix, it's here. Order of rows is important, is known, order of columns is known, so it's not a relational table, but we can use it in the same way. I don't need a connection anymore. So I can first get some summary of data sets. So what are number of cars owned, minimum, maximum, median, mean, and so on. Calculate some other statistics for number of cars owned, aggregate statistics in groups of gender and education, and so on. And even plot this again by installing additional package, which is already installed. And now I can get comprehension of my data. So for example, I'm analyzing education in different regions. Okay. Now time to go to real analysis. So again, I have another package for NeoBase. This is really a big confusion. You have many packages that overlap for the same thing. So I'm building the model using R syntax. This means using this matrix data frame. First rows, no filter, means all rows, and then columns 2 to 11, because first column is customer key. I'm skipping customer key. And last column, 12th column, is bike buyer. This is the target. So you see, it's position aware. And because it's position aware, the syntax is ugly. SQL syntax is clear. So I can check a priori probabilities. So this is a priori. I have nearly 50% of buyers, 45% of buyers. Okay. So let's try predictions. And this is now NeoBase was trained. This is doing the predictions. Of course, this is just textual result, doesn't help me much. For this case, this is prediction for, I think, value 0 and probability for value 1. It's somewhere up. I can make this nicer. I can create a data frame with these predictions. And I can combine data frame with original data frame. And please note, this is not a join. I'm combining first row with first row. I don't have any join condition. But it works. This is not relational, this is purely statistical. And now I have, did I do it? Did I run it? Okay, now I have it. So now I can use these results for testing. So you see, I have initial value of bike buyer, and for this first row, the prediction is 21% of probability for not buying and 78% for buying. Let's say that I put a limit, a threshold at 50%, so this would be a correct prediction. Some predictions could be also incorrect. Of course, they are. Let me try to find some. Yeah, here you can see, for example, this one is actually a bike buyer. This person is a bike buyer here. Let me focus here. I cannot. Yeah, this. So this one is bike buyer, and the prediction is 88% of not buying. So apparently this is the wrong prediction. Similarly, I can create decision trees using another library. I have shown this library yesterday. I love this library. You see, this is academic world, so people are doing this for free. I'm developing my own decision tree, so I don't care what you think about it. It's my naming convention. So library is called party, and then it's including depending packages, which are called zoo and sandwich. So this is one of the problems, with R. Without help, you are lost. How would you know that you need library sandwich for decision trees? Some decided, some developer decided, or statistician, that these are nice names. And such libraries are basically forbidden in Azure ML. Microsoft tries to select those who make sense. So you see, I got a decision tree, and not so good viewer, but viewer. And then there is also a library that is built in, so I have another way of building decision trees. So in R, everything can be done in multiple ways. So let me plot the decision tree. different viewer, different plot, but again, similar results. Oh, this one tree didn't grow fully because I used only 2 input variables to make this faster, okay? But basically it's a similar algorithm. Neural network. This initially started to develop in 80s with artificial intelligence and initially promised a lot. It's still used in artificial intelligence a lot, also in data mining, but mostly for controlling decision trees. It's more complex algorithm, and because it's more complex, it's harder to understand the results. And basically, usually doesn't give better predictions than decision trees, especially when we are talking about real decisions about people. So how does neural network work? We define every input variable as an input unit. And then we combine them in units in a hidden layer. Hidden layer means you don't see it. It's hidden, it's inside the algorithm, inside the processing. You see inputs and you see outputs, right? You can have 0 or more hidden layers. And then you combine data from units into single output, and then you declare this output as my prediction. Now, what do you do in these units? How do you combine data? You combine data with weighted sum, and then you get a single number. And then, before passing this data to the next layer, you do some non-linear transformation, non-linear function. And these non-linear functions are either hyperbolic tangent in hidden layers, or in the last output layer is also a so-called sigmoid function. I will introduce both functions in a minute. Now, this is the first pass. Now remember, my target variable is bike buyer, so I get some value. Now I can compare to the real value, but I can use this also for additional training with backpropagation process. So I can measure how many times did I fail with my prediction. So I go back and correct the weights. Simply correct the weights and try again and again until some stopping criteria. It turns out, you see that with neural networks, you can have, as I said, from 0 to n levels of hidden layers. Turns out that we rarely use more than one hidden layer. Remember, each hidden layer gives you additional nonlinear transformation. So with multiple hidden layers, it's impossible to reconstruct how did you get there. Either you use neural network completely as a black box, or don't use, if you want to get some more understanding how did you get there, don't use more than one hidden layer. Actually, in analysis services, this is hard-coded limitation, one hidden layer. In R, you can define everything. You have multiple implementations, so you have also implementations where you can define this different hidden number of hidden layers. Now, remember that nonlinear transformation in the output layer is called sigmoid function, which has another name. It's also called logistic function. So basically, if I get rid of this hidden layer, I got only the sigmoid function. So what is a logistic regression? Logistic regression is a very simple neural network without a hidden layer. That's it. So you see, very simple algorithm. And let me introduce this tangent hyperbolicus and sigmoid function. So this is the shape. Shapes are quite similar. Both also limit the possible range of values of the output. So hyperbolic tangent gives you values between -1 and +1, while sigmoid between 0 and 1. And then depends on the values of the input or target variable. You split this in classes and say this is prediction for class 1, for class 2, and so on. So these are these functions. So, like decision trees, you use neural network and logistic regression for classification and prediction. The problem is that interpretation can be a bit complex. So let me quickly create, maybe only in Visual Studio, it will be the quickest, go to mining models and add a neural network model. Okay, and add logistic regression model, and I'm prepared. Let me deploy it. And now I have also 4 models to compare. Because it's kind of hard to understand, to interpret the results, also we don't have many viewers, which also limits the usability. So let's go to mining model viewer, go to neural network. I'm having problems with names. So we have only one viewer, only this attribute discrimination. There is no other viewer. All I can do is just filter this and say, let's check this for high school education only. And very similarly for logistic regression, I have only one viewer besides the generic content. So not so useful for interpretation, kind of hard to get the idea. And the viewers are even worse in R. Okay. Let me just quickly show you an example of neural network, just to get you the idea. Again, another package for neural net, at least this one has logical name. Limit the dataset so it will be faster, limit the inputs, and limit to one hidden layer. And let me plot the neural network. So, sorry. Wrong data set. Let me first load the data set. Okay, and build the neural network. What? Didn't redefine this subset again. Okay, now let me show you the plot of this very basic one, just the network, so not really useful for interpretation. But now we have 4 different models, so now we can evaluate them. Which one gives us the best results? Maybe I don't even care about the interpretation of neural network if it gives me good results. So first we have training and test set. So this is how you can evaluate predictive models. So we trained the models on 70% of data. Now we will use the test set. Analysis services set aside the test set. Remember, it's important to randomly split this. The most important tool for evaluating predictive models is lift chart. So I have different models and additional 2 lines, especially for target value. This is the real lift chart. I have ideal model line and the random guess model line. And you are measuring the lift from the random guess model, and the higher the lift, the better the model. So I will show this directly on an example. And explain the numbers. From lift chart, it's easy to create profit chart. Why would you create profit chart? Well, you see, you select, we have target mailing campaign. We want to pre-select the most probable buyers. So what is the percentage of all possible buyers I've got to select? What is the best percentage so I maximize my profit? So you can change lift chart to a profit chart if you define fixed costs, cost per case, and profit per case. And then you get the probability that this case is a bike buyer. So you can easily calculate where is the cutting point, maybe here. Classification matrix. This is useful only for binary classification, like bike buyer 0, 1. Then you can define what was predicted and what was actual, and what was true positive prediction, what was true negative prediction, false positive prediction, and false negative prediction. And then you can combine this in different calculations, like accuracy, true positive rate, false positive rate, and depends what is your goal. You see, you define which factor you use to evaluate models. So for example, let's say that cost per case is very high. So if you define somebody as a positive case but it's actually negative, then this false positive rate might be the most important thing for you because you don't want to pay this high cost. And all other combinations, true negative rate, false negative rate, and precision proportion of positive cases that were correct. So this is just combinations of these numbers, and you combine them based on your business problem. And finally, and this is the test I will not do, I will do only lift chart, but just to mention, cross-validation, it takes a long time. So what is cross-validation? Cross-validation is retraining all of the models multiple times. It might be important to do it again. It's very important to work on samples. So you define so-called faults. So for example, you define 10 faults in your data. And then it means you are creating 10 times all of the models. So analysis services will use first fault as test and all other 9 as training. And then second as test and all other 9 as training, and so on. And then it will calculate all of these true positive rates, false positive rates for every single model. And then it will calculate mean of this true positive. So like 80% of time is mean true positive, and standard deviation, which tells you how these predictions vary based on subset of data. So this is important to test robustness of model. Lift chart gives you efficiency, but this gives you robustness. So if standard deviation of these predictions is high, it means that with small changes in data, you can get a big difference in prediction. So maybe even if lift chart gives you very good results for a model, but the model is unstable for small changes of data, you maybe don't want to introduce this model in production. So let me create a lift chart, which is very simple in analysis services if you have the same structure like I've got. So I got to mining accuracy chart, and I'm interested in value 1. And I will use mining structure. Remember, these 30% cases I set aside for the whole structure, not just for a single model. So I'm using this testing for all of the models at the same time. And this is lift chart. So this is my lift chart. Now let me explain these lines. So this is random guess line. Apparently I have, remember, around 49% of bike buyers. So my potential buyers are in big box. If I select 80% of cases out of this big box randomly, I will get 80% of bike buyers. In ideal case, if I would know exactly who buys a bike, if I would use this knowledge, I would need to select only 49% of cases to get 100% of bike buyers. And of course, the models are somewhere in between. So the highest the line is for this violet, which is NB, which means decision trees in our case. Remember? Okay, so this is, so decision trees was the best here. Others were lower, logistic, neo-bears. But of course, as I said, I should also test the cross-validation especially, to test the robustness of these models. Maybe decision trees is prone to give you much worse predictions with small changes in a data set. One more thing, cliff chart is also very useful for evaluating if the model is overfitting. You see, this line must be smooth. This line must be smooth. If it goes like this in steps, when it goes to the end of the step, it's nearly ideal. We are not living in ideal world, so you simply know that this is wrong. So you go back to the model, change some parameters, like raise the number of cases, which is by default 10 in a branch. So raise this to 20 or something to prevent this overfitting. You don't want to have predictions that are very good for you, but not true. Okay, right in time. the Big Ben was there, so right in time. Any questions?
Just one with using different libraries from R. So you say you can get multiple different libraries that would give you a naive Bayes implementation. Presumably if you fed the same data into those, would they all give you the same results?
No. So these are different implementations. Sorry, no. Yeah. And this is the clumsiest part in R. I mean, it's impossible to test all of different implementations, and don't forget that also because just naming is inconsistent. You can't do it quickly. First, you Google to find which package has this algorithm, then you install the package, and next thing is help to find what does sandwich mean.
Would that mean that there could be one which would actually do a better job of classifying your data, but for someone else it might be different?
Yes, exactly. And remember when I said how do you conduct a data mining project, you define the time frame, and then you finish at some point, but then you measure it over time, so even if you didn't get the best one, maybe you can test it later. Okay, so thank you very much, and I hope we see in half an hour for the second part. More how these things work, and I'll try to unveil this black box. And once you have this knowledge, then you can realize and understand when to use which algorithm, why some algorithm gives you better results than another. Also maybe to realize what are the dangerous points. So not all algorithms are useful for all kinds of data, and because it is kind of black box like analysis services or Azure ML, you will simply get some results. Although it would be better to use your experience, evaluations over the top, predictions over the top, and not use data mining at all for a specific task, because some algorithms are very prone to give you weird results with some specific kinds of data. Okay. Also, sometimes there's even a problem how to interpret the results. Data mining is business oriented, so after you did all of the modeling and trained the models, you want to use these models to improve your business, whatever, improve your return on investment. And if you don't understand properly the results, of course, it is hard to use this in production. So this is what we are going to talk about, and also show how these algorithms work in analysis services in a simplified way in Excel and in a more complex way in R. And since R is also supported in Azure ML, this means that also this knowledge is applicable to Azure ML as well. And of course, I need to say also that all of these data mining algorithms are public domain. So this is kind of habit in data mining field. So it started to develop in 50s with statistics and then went to data mining in academic world. So it was always like this. All of the algorithms were public domain. So the difference is how these algorithms are implemented. So what I'm trying to say that what you will learn today is also applicable on other data mining products like SPSS, SAS. They use the same algorithms. And also, for example, we'll talk about sequence clustering, which is an algorithm developed by Microsoft. And Microsoft respects these rules or this conduct of behavior in data mining area. So also sequence clustering algorithm is published completely in Microsoft research sites, so competitors can use this information and build their own solutions. Now a little bit of my assumptions. So this is not introduction to SQL Server, analysis services, Excel or R. I do expect that you know at least one of these tools. Do not need to know all of them. And also I will use Visual Studio, SQL Server Management Studio, Excel, R Studio. Nothing specific there. I will not spend a lot of time on the tools. So I expect that you know at least one of them. And I will show examples in multiple tools. So even if you don't know all of the tools, it doesn't matter. You will get enough information. But the focus is on the algorithms, how the algorithms. Good morning. Thank you for coming to this conference and to visit this session. This and next session, I'm going to introduce data mining algorithms. So there are many algorithms. I will introduce the most popular ones. And of course, even for the most popular ones, I need 2 sessions. My name is Dejan Sarka. I am in the field for nearly 30 years. And actually, my career started with working in university for statistics. I did a lot of statistics and early data mining in 80s. And then I switched more to Microsoft and SQL Server side. And of course, there is strong support for data mining in analysis services, in Excel, and now even in Azure machine learning. So if you have any question, even after the conference, these are my contacts, email, Twitter handle, so please do not hesitate to contact me. Maybe I will need some time to answer, but I will try to answer all of the questions. So what I'm going to talk about, this first part, I will introduce data mining first, so you get the idea what exactly this is. And then I'm going to talk about predictive algorithms, predictive or also classification algorithms, how they work. Naive Bayes, decision trees, neural networks, and logistic regression, and also describe how we can evaluate the efficiency of these models so we can decide which one to deploy in production. Let me just jump here. This is for the second part, so there will be no introduction to data mining, but I will talk about linear regression, regression trees, support vector machines, forecasting with time series, clustering, association rules, and sequence clustering. So even more algorithms in the second part. Apparently somebody forgot this, thank you.
It's not mine.
Nice device. It doesn't look too smart. Okay. So, what is data mining? Let's start. So you know that this is maybe the most advanced data analysis technique we got, the most advanced part of business intelligence. And with these products we got, and packages, especially with Microsoft Suite, less with R, which is more like programming language, but especially with Microsoft Suite, you use data mining like it was a black box. So you feed it with data and you get some results. Well, the problem is, you know, if you give an ape computer, this ape will not become a mathematician. It will be just an ape with a computer. That's it. So with a calculator. So you need to know a bit from more data. But mathematics behind is kind of simple. Just learn from the example. So more examples, better results. The other part, and what you see nowadays, if you go to Azure ML, you will see mostly or only data mining algorithms. These are currently available, only data mining. So in this part, machine learning and data mining are synonyms. And finally, also worth mentioning, data mining and machine learning, this is business, statistics is science. So the main difference is really funny, but the main difference is with statistics, you test the hypothesis. If you get the result that hypothesis is wrong, basically you get no result. This is result for science. This is not result for business. Customer will not pay you. So you try with a different algorithm, change something in your data set you are using for training and so on until you get some result. So it's not science. So we are deducing knowledge by examining data, and then we use this knowledge to make predictions, estimations, forecasts, and so on. Now, also worth mentioning, if we compare this to online analytical processing, this is still model-based. We create all-up cubes in advance, we define dimensions, attributes, hierarchies in advance, and then we are limiting there. And we try to find patterns by visually analyzing this data. Data mining starts from the other direction. We just include all possible attributes we got. And then it's mathematics behind that tries to find these patterns that should be useful for us. There are two main types of data mining, so-called directed or supervised data mining. Here is where we have a target variable. By the way, in data mining terminology, we are analyzing cases using their variables, and this is terminology that comes from statistics. Basically, what you are analyzing is a table, and cases are rows and variables are columns. So here we have a target variable that supervises the training of the model. So this is what we are going to talk about in this first module, for example, decision trees. Target variable denotes some kind of decision, true, false, or even more classes, but it's discrete. And then you use input variables to try to explain how did we come to this decision. And once you got the knowledge, you save this knowledge in a trained model, and then you use this knowledge for predictions of the target variable on new data. So you get some new examples with known input variables, so you try to get the value of the target variable to predict it. Now, estimation is very similar thing, just that the target variable is a continuous one, like income or age or something like this, a continuous variable. And you use one or more continuous variables as inputs, but also you can use discrete variables as inputs, and then you try to estimate the value of the target variable. So for example, if you are in a bank and you have a new customer asking for loan, you can try to estimate the family income based on the demographic data you got from the customer. And forecasting is again something similar. Similar to estimating, you try to forecast some target continuous variable like sales amount in next year, so you can make better plan, better budgeting. The main difference is that prediction and estimation, you can check these estimates and predictions immediately. You know, like you have this customer asking for loan, you estimate the income, and then you can ask. For forecasting, you can check the quality only after time. You don't know the number for the next year yet. But after this time comes, you see how forecast were good or bad. Undirected or unsupervised data mining, you don't have a target variable, you just try to find some patterns from the combinations of the values of the input variables. And what are these patterns? Well, for example, we are searching for combinations of products that are sold in a single transaction, market basket analysis. And we are searching for groups or clusters of our customers. So we see if there is any specific grouping inside my customers, employees, whatever. So classical clustering. Even some visualizations can help you here, although I would not count these descriptive statistics and visualizations exactly into data mining. It's probably more like preliminary part of data mining. So what are typical business questions? As we mentioned, what is the credit risk of a customer? Are there any specific groups? What products do customers tend to buy together? So what will be my sales amount in next time period? Potential number of customers in a specific store? And how is my website used? Can I improve something here? And of course, these are just very well-known questions. Of course, it's only up to your imagination. You can use data mining for whatever you wish, whatever needs to be improved by better predictions. But there is a time and place for everything. I will tell you my experience with word in wrong time and wrong place. So a couple of years ago, I broke my knee, so I had a couple of surgery operations, and of course, I was there, and one operation and waited for 2 weeks, and I was bored. Then once I said to one of the doctors that I could help them lowering the mortality rate in this hospital, and all I get was extra dose of sedatives. So, word out of place and time. So, okay, but basically it's up to you to get the algorithms work, how they get their results. First, a little bit of definition of data mining. Might be especially interesting to try to separate it from statistics and from machine learning. More or less, many times we use these terms even as synonyms. So let me start with the first, little bit more formal definition. The process of exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover patterns and rules. First, I would like to comment these large quantities of data. You see, data mining started to develop from statistics. And in statistics, we are working on samples. And we have two different branches of statistics, one that works on small samples and one that works on large samples. And small samples means 30 cases or less. That's small. Large means 200 rows or 200 cases or more. So this is large for data mining. It doesn't mean millions or billions of cases, 200 and more. And from statistical sampling, you can learn that like 20,000 cases is more than enough to learn good patterns. And you never need more than 100,000 cases for data mining algorithms. So, if we talk about the amount of data you are analyzing, data mining is not dealing with small samples. This is different from statistics. Now, this big is compared to statistics. What about machine learning? Machine learning is definitely using all of data mining algorithms. So whenever in Azure ML you are using one of these algorithms, you deal with the same samples. These are complex algorithms which scan data maybe 1,000 times in 1,000 iterations before they get the result. So if you fit these algorithms with millions and millions of rows, you will wait for days or even weeks before you get the result. And also the results will not be better because these algorithms come from statistics and they are tailored to work on samples. That's it. So feeding them with more data doesn't give you better results. Yet there is a part of machine learning that is really focused on machines only. And this part uses simple mathematics, but can gain a lot from huge amounts of data. And this is the part where really, as I said, machines learn. So for example, we all have smartphones, and you know these keyboards are very small, these keys are very small, and yet you don't make many errors. This is not because you would be so good at typing and you would have so precise fingers. This is because Google and Apple and Microsoft spent a lot of time to teach this software how to recognize what you want to type. Or, for example, Xbox can detect your moves, right? This kind of algorithms, these are pure machine learning algorithms. These algorithms can benefit